Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Maxwell's House is brought to you by CacheFly at CacheFly.com. This is Maxwell's House with Ray Maxwell, episode 55 for January 15th, 2010. 3D Tech. It's time for Maxwell's House, the show that covers whatever is in the mind of Maxwell. Ray Maxwell is a Canadian-based raconteur, scientist, color scientist, pilot, glider pilot, photographer, Photoshop wizard, ham radio operator. In fact, if there's what is that Ray hasn't? Are you a good cook too, Ray?
It's just so.
Okay, good. Finally, we found something Ray can't do. Well, barbecue. I'm sure he's an expert on that too. Hey, Ray Maxwell, how are you today?
I'm doing great, Leo.
You've got a subject for today.
Yes, indeed.
I'm very excited about. In fact, while this is an audio podcast and it's you can listen, we're also going to put a version of this up on YouTube so that people can see, because there is a lot to be seen in this subject. What are we talking about today?
We're going to be talking about the technology behind 3D or stereoscopic vision, binocular vision of human beings, the technology behind that in theaters.
So when you went to see Avatar, for instance, or Up,
yep,
if you saw it in 3D.
I saw it in 3D, and that triggered my research into this area. And the deeper I dug, the more interesting it got.
The digger I deeped, the more I found. Good. I'm very interested. And, I have to say that we're just back, as you know, from the Consumer Electronics Show, and the story of the show, one of a couple, but one of the biggest stories of the show was 3D television.
Yes.
And I was not a fan. You have to wear glasses, etc. And one of the things I looked for is anybody who had an idea of how to do this without glasses. And the funny thing is, there isn't.
Mm-hmm.
But so we're going to find out why,
right,
and how they do it. And is this related to 3D TV, or is this really only how it's done in the movie theater?
I think they're related. I want to do, before I say anything about the television, I want more time to research it.
Okay.
Because now, to be fair, if you have a projection television system, Real D already has an industrial strength projection system that could be installed in a home if you're rich enough.
Okay.
But,
I have to say, there was we saw the Toshiba 3D. I mean, I saw all of them, but in the Toshiba 3D, the glasses were prominently labeled Real D.
Right.
I don't know what that means, but they were actually, ironically, they were labeled Real D, but they needed batteries. They were active. So now I'm really confused.
Oh, that doesn't add up.
It might have been a Real D ad, frankly, that was that they paid for on the side. Right. Anyway, but let's talk about movies.
Yeah. Now we're going to need GoToMeeting.
Yes. I'll launch GoToMeeting. We use GoToMeeting on the show so that Ray can control his own screenshots, and that works quite well, I have to say. Let me just
because what I have today is I have a bunch of slides that are from a talk given by Matt Cowan of Real D. But we're not going to just talk about Real D. I'm going to talk about all the 3D methods and compare them. And I'll let the cat out of the bag. I think in theaters, there's very good reason why Real D is likely going to be the winner in that area. And as we go along,
I'm very curious to hear this, because I talked a day before yesterday with a special effects supervisor for Avatar. Mm-hmm. And I mentioned that I saw it in Real D, and he said, yeah, most of the theaters are doing it in Real D. He said, my preference is Dolby 3D.
Yep.
And he said, and I said, what about IMAX? He said, no, I don't think that Avatar particularly was well suited to the IMAX screen. It wasn't designed for IMAX. He said that his preference as a special effects supervisor, and he just came back from a year at WIDA in New Zealand. I mean, this guy was there on the ground, 3 years or 4 years with Jim Cameron working on this. He said, my preference is Dolby, but we'll find out what the differences are, because that's I'm very curious about that.
the quality of the Dolby is outstanding, but as we go through it, you'll see there's a drawback that gives Real D an advantage for the theater owner.
All right. Well, let me go to meeting, and you want to set us up while I get those slides ready? Go right ahead.
Okay. Well, what triggered all this with me was I went to see Avatar, and I saw it in Real D. I could have seen it in IMAX, but I wanted to see Real D. I have seen 3D movies at IMAX numerous times, and I had not seen a movie in Real D, so I wanted to see Real D. And I still haven't seen one in Dolby, but I have researched that quite thoroughly. And another little preference, this is a subject near and dear to my heart because while I was at university, I worked at night as a projectionist. Back in the good old days when before xenon lamps and before the typical roll of film that you loaded into the projector, and you had 2 projectors, was only 20 minutes long. And you had to trim the carbon arcs and rewind the previous
trim
roll
the
of
carbon arcs. That's like that's like were you using kerosene? What?
No, they were high amperage carbon arcs. I worked at a drive-in theater, and so they were really big arc boxes.
They had to be bright,
and they were water cooled. And one night in the middle of the movie, one of my circulation pumps went out. And so the manager of the theater came in, and one of us, I kept the movie going, and he changed the pump in mid stripe. But
they don't use carbon arcs anymore, do they?
No, it's almost all xenon lamps now. And by the way, this is something that has really had a big effect on the projectionist union. Again, when I was doing this at university, now I was in a university town. It was totally non-union because there was a surplus of university students that would do this work. But in the big cities, it's a highly unionized job, and you have to practically be born into it. In the old days, because the projectionist was busy all the time.
Oh, interesting.
I mean, you were working your backside off to keep that show going all the time because you had 20 minutes and then you did a change. You've seen those little circular marks up in the upper right-hand corner. Those are called cue marks, and that tells the projectionist when to start the motor on the other projector. And then you have a set of shutters that close down on one and lift, open one projector and start the other. And you have to flip a switch that takes the sound from one to the other.
Wow.
And you do a change from one projector to the other, and the people in the theater never know. But all of that is history because now the film productions come to the theaters all in one reel.
Oh, really? So you no longer have to have those dots?
And it's a continuous loop. You don't even rewind.
It just keeps keeps going.
Yeah, and it has a cue thing on it that stops it when it gets to the end. And it's cued for the next show. So they can set a timer to turn the projector on and start it.
Nobody has to be in there at all.
Nobody has to be in the projection booth at all.
And in our theater here in Petaluma is all digital with DLP. So I imagine that the cashier is probably pushing the button to start the movie. I mean, there's probably there's probably not even room anymore.
From what I understand, there are no projectionists. There are now a theater technician who comes in every time they change the film and sets it up or sets up the server if it's digital. And then he can put it on a timer. It could be started with a button from the manager's office, whatever.
Wow.
But it is completely automated, much to the chagrin of the projectionist and projectionist unions.
I have your slides ready, my friend. You stalled like a pro. Well done.
Well, what we're going to do, like I said, I want to give credit to Matt Cowan, who gave a talk. I have extracted some of his slides, and I'm going to use them on the show today because I find them very, very interesting. So the first thing, let's go back to the good old days. I saw my first 3D movie in the 1950s, and the way they did it is they had 2 projectors and 2 rolls of film, And by the way, we had a shaft that went between the two projectors to keep them synchronized. In other words, they were mechanically locked.
Wow.
And you had giant magazines that would hold about an hour of film instead of 20 minutes. And you had to trim the arc with a brand new carbon before you started the show, because it was limited by how long the carbon would burn and how big a roll of film you could load. But there was always an intermission if the thing ran over an hour, because you had to change all this stuff.
Wow.
And also, if the film broke and was damaged, you had to splice in black film.
Equal lengths as well.
Equal lengths to keep it synchronized.
Jiminy. So you could see the problem. Was House of Wax, the Vincent Price movie, was that the first?
I'm not sure. It was
the
one
first
of the
I'm
early.
aware of.
I remember it.
Yeah. And that was the famous red and green glasses. You always saw those pictures of people in the theater with their 3D glasses on, looking amazed.
Now later they came out with the linear polarized glasses, and you used polarizing lenses on the two projectors rather than the red and green. And but I remember they were cardboard, and if they were sprayed, and if you touched the lens, it ruined it.
Oh,
one touch, it was all over. Now the other
here's the famous image that everybody knows.
Yes,
of people wearing those silly glasses, and we're back, baby. 50 years later, we're back.
Right. Now let me just show you something. What one of the problem was with that early technology. I'm going to use my iPhone, which a lot of people don't know, but it puts out polarized light.
Oh,
all TFT LCD panels, the light that's coming out of them is polarized. And here I have a linear polarizer. And if I put it in front of this and I turn it, you can see it. If I get it just right, it blanks out.
Yep, it's working.
Okay.
Yep. So now we see nothing on your screen because you've turned the filter to the polarization that blocks the light.
It blocks the light. Now,
what is that? I always think of this as like Venetian blinds, that the light is coming out in horizontal, let's say horizontal strips, and you've got a lens that has horizontal strips. When they match up, the light comes through fully, but when you're rotated 90 degrees, it blocks the light.
Right. Now, notice that it's very sensitive to the, I don't have to rotate it very far before I start seeing light come through it.
Right.
And if you have glasses that are like that in the theater, if you just tilt your head slightly, you start getting crosstalk between the two channels.
No, we don't want that.
Do you remember that with the early 3D?
No, I never went to see House of Wax. I'm sorry. But I believe you.
Later, I'm going to demonstrate circular polarization. But let's carry on here with our slides. And he asked the question, is today's 3D any better? And the answer is yes, by far.
Yeah.
It must be comfortable to watch, no headaches, because people used to get headaches from if the two cameras were just slightly out of vertical alignment. Your eyes had to one go up and one go down, and the muscles in your eyes would give you headaches.
Horrible.
And of course they did a lot of overuse of 3D, and they say gratuitous in-your-face 3D, and I'm going to talk about that later. And it requires that you craft the story to use the 3D intelligently. Now we're going to go back and pick up on the science of stereoscopic basics here. I want to point out that what we're talking about here is we're talking about your eyes turning inward and outward to do binocular vision. In other words, when you have something moved up close to your face, your eyes tend to cross in order to focus on that object. Now, there is an additional thing that's happening that a lot of people aren't aware of. As something comes near your face, your eyes tend to converge on it, but simultaneously with that, your eyes will, as they turn in to focus on that close object, the muscles in your eyes, if you're young, will focus your eyes on something close. So there's two things happening. Your eye muscles are turning in, all right, and focusing on something close. So if you have at a 3D theater something come out of the screen and look like it's a foot from your nose, but you're still focused on the screen to get a clear image, that isn't natural. And that's why the gimmicky 3D that comes out at you, some people, it goes out of focus for them. Because their eyes, when they're caused to turn in like that, simultaneously will focus on something close, and the image is still on the screen.
Right.
There's two images.
Right.
And so the distance is wrong for the parallax.
I think that's what happens to me. I don't like what happens.
And that sometimes gives people a headache as well.
Yeah.
So having it come out of the screen, and again, I'm going to come back to that in a minute. But there are limits to the comfort when they, make that stuff jump out.
That's why I hate those effects. It really bugs me. Besides the fact that aesthetically, I think it just takes you out of the movie. It distracts you.
Right. It distracts.
It's a special effect. It's an amusement park ride.
You noticed in Avatar, but in Avatar, the majority of the depth was behind the screen.
Right. Well,
did you notice that?
Yeah, there were people wandering in front of me. There were snowflakes falling in my lap.
Yeah.
Jim Cameron said there were 3 specific moments in the movie where he actually did a 3D effect. He said, I only did 3. It's 3 too many.
But he's talking about stuff coming out.
Coming at you like a spear.
Okay.
Yeah.
And by the way, most of the things that were coming out of the screen were very small and incidental to the main action.
Except that.
Like the snowflakes.
They become foreground by virtue of the fact that you go, whoa, there's a snowflake. And you're suddenly not paying any attention to the movie.
Well,
I would have preferred to see Avatar in 2D. You can tell by now.
Right. I can tell that. So, also, though, now here, let's go through these diagrams. What we have on this diagram is if the images on the screen for right and left eye.
I like those eyes, by the way. Those
exactly. I'm sorry?
Very big eyes.
Yeah. Don't you love those?
Yeah.
If that image is exactly the same place on the screen, it will appear to be at the screen for you.
Right.
All right. Now, if, on the other hand, we actually cross the images, it will appear to come out of the screen, as shown in this diagram. Okay. And that, is equivalent to something being shoved right up in your face. And then if we move the objects apart in the other direction on the screen, it appears to be behind the screen. And most of the depth in Avatar was behind the screen. I took note of that as I was watching it. And to me, that's much more natural. Okay, the other thing that has problems is these systems, the new digital systems, rather than 2 projectors, do it all with 1 projector, and they give you the frames sequentially. They give you a frame for your left eye, and then a frame for your right eye, and a frame for your left eye. And so the motion, when there's motion, your left and right eye aren't getting the same information. And if you do that at the normal 24 frames per second, it's very disturbing. Okay, you can see it jumping. You go left, right, and it drives you batty. So what they do, and let me digress and back up the truck. Let me ask you a question. How many frames per second were in a conventional movie?
24.
24. Can the eye see flashing at 24 flashes per second?
I would say yes.
It can.
Yeah.
And so people say, well, wait a minute. I've seen hundreds of movies, and I never noticed a lot of flashing. They have a shutter in the projector that flashes each frame twice. So the flash rate is 48 frames per second, or 48 flashes per second. Because if it's any slower than that, you can see it.
Right. Okay.
So the frame changes 24 times a second, but the frame is flashed onto the screen 48 times a second. Now, so what they did when they went to digital projectors in 3D is they started out using, let me go to the next slide here. They started out using double flash. And so the projector, the digital projector, had to be capable of sending 96 different frames per second. And it did it in the following order. It sent the left frame of frame number 1, then the right frame of frame number 1. Then it repeated left 1, right 1. Then, after showing all 4 of those, it then moved to the next frame in the picture. So it double flashed each left and right channel times 24 times per second. So you ended up with 96 frames per second. In other words, the digital projector had to be able to change images 96 times per second. You follow me there?
Yep.
All right. To get smoother motion with 3D, they went to what's called triple flash. And now they send left 1, right 1, left 1, right 1, left 1, right 1, 3 times. And then they go, left 2, right 2, left 2, right 2. But that requires a digital projector that can change the frames 144 times per second. So it's 24 times 3 times 2 channels. So they're using triple flashing in this digital projection method. Now, here's a really interesting thing that I hadn't really thought about. And remember, this is a chief scientist for RealD putting up this presentation, and he points out that an image at infinity appears with a 65 millimeter offset. Now, that's the distance between your eyes.
Okay.
All right?
That's the actual distance between your eyes.
Yeah.
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 Average, of course. Yeah.
Average. The offset in the master means that a 65 millimeter offset for a 30-foot screen becomes 5 inches offset on a 60-foot screen. Parallax does not scale with screen size.
Oh, that's interesting.
All right? So the difference in parallax for a TV screen is not optimal for the difference in parallax on a theater screen. See, are you with me? What I'm saying here? The distance between your eyes, the viewer, doesn't change.
No, of course
whether
not.
you're looking at a movie theater or whether you're looking at a TV screen.
Right.
But if you want the same dimensional feeling,
you have to allow for that.
Yeah.
Yeah.
Okay. So he says, in practice, an offset for a 12-meter screen distance seems to be a good compromise for large and small screens. In other words, you can get by without remastering the thing for the 2. But if you really want the very best quality, that's what you need to do. And that's an aspect of it I hadn't really thought about. But it makes complete sense when you go through the steps. Now, here's one that I knew that old projectors, I'm talking about film projectors, they have a jitter, a vertical jitter. And that vertical jitter, if you have 2 projectors and they're not, and the jitter isn't exactly the same, will cause vertical parallax, where your eyes then, one needs to be shifting up and down slightly to merge the image in your brain.
That's nice. That wouldn't happen in a digital projection, though.
No.
Only in a physical projection.
That's right. Yeah. Now, one of the things I've always gotten, I'm going to digress a moment. One of the things that's always, frankly, annoyed the heck out of me as an engineer is for Final Cut Pro, and I do video editing and I have Final Cut Pro, and you can buy a set of modules that put all of the faults of a movie system into your video. You can add grain. You can add vertical jitter. You can shoot at 24 frames a second instead of 30, so it looks like a movie. Now, what I find really funny is the IMAX people went to great lengths. They don't have that jitter. Their mechanism is entirely different than a conventional projector. When at Expo 86 here in Vancouver, the World's Fair, they had show scan projectors that went at, I can't remember, 50 frames per second or something, and were CinemaScope and 3D and everything. But all I'm saying is the engineers who build projectors have been trying to get rid of this, but you can go out and buy a filter for Final Cut Pro to put all this, in my opinion, crap back in. But for some people, it's very important, that it looks like a movie. Okay, so that was vertical parallax. Now, let's go through the kinds of theater systems that are out there. The first one, and by the way, IMAX is this first one. IMAX uses it's a double projector. It has two separate lenses, two separate lighthouses. It's built into one case. But if you go and look at an IMAX 3D projector, it has two lenses coming out of it. It has linear polarizers on the front of it, and it uses linear polarized lenses. And so once again, if you tilt your head, you start to get crosstalk. I've sat in the IMAX theater and, of course, tried that because but it requires that you sit with your head, absolutely vertical if you want maximum separation in the left and right channels.
You do see occasionally people complain about, and I don't know if it's just IMAX or other technologies, ghosting. I think Real 3D has some ghosting images, and I guess that's why your head's not exactly upright.
Right. If you turn your head slightly, you get ghosting instantly.
Well, that sucks.
Yeah. So that's one of the drawbacks. But now, I want to be fair here. If you see a 3D movie in IMAX that's been shot in IMAX, the data rate, if you will, the fact that the frame area is 10 times the size of a 35 millimeter print that's shown in a movie house, it's dynamite. It's sharp, it's clear, the color's beautifully saturated. So, you win a few, you lose a few. The next system, and it's one that is used with television a lot, uses shuttered glasses. So, and the glasses are synchronized, and you sequentially send out the image. Mm-hmm. All right.
I think all PC gaming systems are shuttered, and many of the TV systems are shuttered.
And it lets your left eye look at a frame, and then it cuts it off and lets your right eye look at a frame.
Well, that eliminates the issue of keeping your head upright anyway. Yes?
Yes, that's correct. You now then can turn your head, and it's fine. Right. But it requires an active pair of glasses that I think even mass-produced run about $30 a pair.
Yep, and they need batteries
batteries and so forth. You have to have an IR synchronization method or something. And so, they're complicated glasses. The next one is a projector with what they call a Z screen. It's a Z screen in Canada and England. And you can use it with passive glasses that use circular polarization. And then the last method that we're going to look at is a projector. By the way, the last three are all one projector. The last one is a projector with a spectral division. And I'm going to go into what they use, very narrow interference filters, and they separate the left and right channel via spectrum and still maintain full color. I mean, they're using the same basic technique as your old red and blue glasses, but they're using much narrower bands. And I've got diagrams here where we'll go through it. So let me step on, and here's the full diagram. Here is the diagram of the passive two-projector stereo system. And so here you can see that we have a projector with a polarizer in front of it and a second projector with a polarizer, and they're aligned to produce an image directly on the screen. And then you have the linear polarized glasses, and that's what IMAX is doing. So there's a diagram of it. So we have a left eye source, which can be film or digital, and a right eye source, film or digital. Now, the next ones are all single projector systems, shutter glasses, Real D, and Dolby. Here's the shutter ones. And here you can see you have a high frame rate digital projector, and it sends out a sync signal that alternately opens and closes the LCD shutters on the glasses. So that's a diagram of the shutter system. The downside to that, especially for public theaters, is you have to collect the glasses and clean them and so forth. You can't, and by the way, you lose a few pairs of glasses in people's pockets every time a theater empties, no matter what they are. People.
But these are cheap because they're relatively cheap, right? They're just like sunglasses.
Well, no. These are the.
These are the active ones. Yeah. So these are expensive.
$30 a pop.
That's why they like the passive ones.
So you don't want these going bye-bye, but you have to allow for a certain number.
Right.
When you let 150, 200 people out of a theater,
Right.
all in a big batch, some of them are not going to drop their glasses in the receptacle. So then let's go to Real D. Real D requires a digital projector that can handle 144 frames per second. And then all you have to add, there's 3 things you have to add to this. 4, sorry. You have to have a server that can serve 144 frames per second. Now, it's actually serving 24 times 2, 48 unique frames, and then they're flashed 3 times each. So, but you have to have a projector that can handle that kind of change rate. And but all you do is stick this Z screen in front of this ordinary digital projector, and you use circular polarized lenses, and you can change. Oh, and one other important thing. The screen has to be painted with a special silver paint that does not depolarize the light. If you use a flat matte screen, it will take the polarization out of the light, which is what they used in the old days in theaters. So you have to have a server that can serve the image fast enough, a projector that can do 144 frames per second, the Z screen, passive glasses that, by the way, in quantity cost $1 a pop, so you can let people take them as souvenirs.
Yeah. And
they can tilt their heads, and you have to paint your screen with a silver paint. So that's Real D.
That's the system they use here in Petaluma, and apparently that's the most common system used in the U.S.
And you can see why.
Yep.
Because it requires the least modification to the theater, and the glasses are cheap.
Yep.
And it gives very good quality. Now, here's a picture of the Z screen in front of the projector, and that's just on an arm that swings in front of your projector.
So you don't even change the projector.
No, you want to change from 3D to 2D, swing that out of the way.
That's easy.
You're done.
Yeah.
So that's why I say I think this system is going to win, because it's so simple for the theater owner. Okay, why circular polarization? Because you don't have to worry about head tilt. And now I'm going to do a little demo with my camera.
You've got some 3Ds there.
I've got some 3D glasses here. And I want to tell you a little bit about what circular polarization is, because it's quite fascinating to me. I don't know whether you've ever done it, but, I just showed you the experiment with the linear polarizer, and I used my iPhone as a source of polarized light. And I don't know, I used to go in the theater, and my wife, would have her linear polarized glasses, and I'd have mine, and I'd grab hers and grab mine. Then I'd put them at right angles and show her how it cut off the light. Well, I went into the theater, and I pulled up these glasses, and I'm going to pull them up here where you can see that white behind them.
Yeah, they look like sunglasses.
I immediately took another pair.
Yeah.
And I thought, well, now if I bring this over here, this is going to blot it out.
It didn't, though.
Doesn't work.
Yeah, well, it makes it a little darker, huh?
It doesn't work.
Well, I thought, that's circular.
What's going on here? So I had to do some research.
Yeah.
Circular polarizers are directional.
Right.
They only work when the light goes through the circular polarizer in the correct direction. Because how they're made up is there are 2 layers. The first layer is an ordinary linear polarizer. The second layer is a quarter wavelength retardation plate. In other words, it's a plate that retards the light by a quarter of a wavelength and changes the phase. So there's a direction involved. So now if I take the 2 pairs of glasses face on, and I now get over here where this is this. Look at this. Here is right over right. Can you see it getting cut off?
It blocks it off completely.
And notice that if I take it over here to this one, which is blocked, it doesn't matter what way I turn it.
It's
still
blocking
blocked.
it no matter what. Yeah.
Yeah. Let me make it a little more vivid for you. Hang on. I'm going to put glasses on you.
He's going to put the glasses on us. Okay, everybody, close your eyes. Oh, okay. Okay. He's got them on us. That's one issue that does come up with these is that they block light ever so slightly. So the image in the movie is not as bright.
Now you're looking through a circular polarizer, and it has cut down the amount of light by half. All right.
That's quite a bit.
Okay. Now I'm going to bring up the other pair of glasses here. Whoops. Have to have them the right way, face to face.
Boy, that sure makes a difference.
And you see how the one is cut?
Zero transmission.
And there's no, the other one's clear.
Yep.
And it doesn't matter which way I turn them. You see that?
Yeah. Very clear. I mean, not literally.
Yeah.
Very obvious.
Very obvious. So that's the beauty of circular polarization.
Now these aren't when I shoot with a filter, I have polarized filters. They're mostly circular on my camera, right?
Yes.
That's what I want on my camera too.
You can get linear or circular. But if you don't put the filter on the right way, it doesn't do anything.
Right.
The light has to come through it in a certain way. So I thought that was an interesting experiment, because I immediately, as soon as we got in the theater, I started playing with them. At first, I thought, this isn't working, but they're directional. You have to have them face to face.
Right.
Okay. Why silver screens? I've already really explained that. Silver screens, a matte screen will depolarize the light. Also, the silver screen gives a higher reflectivity and doesn't lose so much light. Now, this is the magic and the reason why Real D, I think, is going to win the fight. On this, I'm going to have to do. They don't include a diagram of this. I had to do a lot of digging and research to figure out how this system worked. But when you find out how it works and how simple it is, it's just amazing. So now I'm going to hand wave here. So switch back to
hand waving, huh?
Yeah. Normally, there's this Z screen that's in front of the projector light. And this Z screen can change its polarization from right circular to left circular, at 144 frames per second, very, very rapidly. However, as the light comes to the polarizer, half of the light goes through polarized, and the other half that's polarized in the other direction is reflected.
Right.
So that's the problem, is we lose half our light. Right. So you need to then double the lamp strength in the digital projector. Some very bright guy said, wait a minute. I was doing an experiment with polarized light, and you can make right polarized light reverse and become left polarized light.
Mm-hmm.
And you have to have a very exotic device to do this.
What would that be?
It's called a mirror. So when I was in the theater, I didn't know what was going on. I, of course, as soon as the thing started, I turned around and looked at the projector.
Yeah.
And I wanted to see if I could see two channels coming out of it. And I could.
Oh.
And they were stacked vertically. And yet I could, yeah. But I could see that there was really only one projector and one lens up there. And at the time, I couldn't figure out what was going on, but I did my research. Now, listen to this. Imagine I put the Z plane in front of the projector.
Yeah.
And imagine I tilt it 45 degrees. I'm going to do it this way. It's easier on my arms. The light is coming here.
Yeah.
The Z plane.
Yeah.
Half the light goes through it and out to the screen. The other half gets reflected here up. If I put a mirror up here at 45 degrees and aim it out at the screen,
you get 100% of the light.
I get all the light correctly polarized.
Oh, that's so clever. Almost obvious. That's a head slapper. That's like, oh!
Yeah. So they now have Real D XL. And Real D XL has this additional mirror in it. And the Z plane's at 45 degrees. And now you get 100, it's not 100%, there is some loss, but you get twice the light that you would if you only had the Z plane in front of the projector. So now, without changing the light strength, you can take the same digital projector with the same lamp in it and project 2D and 3D movies. Bingo. What theater owner wants to have two light sources? And also, Remember, these are high-powered lamps, burn lots of kilowatts per hour. Well, with the XL system, they burn half as much power, so your operating cost goes down.
Oh, yeah.
So
that's kind of a brilliant and cheap and simple and wow kind of V8 idea. That's amazing.
Right. So now do you see why I say I think Real D
yeah,
has an edge here?
Not for any technical, excellence, but merely because it's cheap and easy to implement.
So here it is. This system, the Real D, is circular polarization, exactly matched to the Z screen. Disposable souvenir for the glasses. They're $1 a pop. You can let everybody take them if they want or throw them in the bucket. Inexpensive and high performance, and the theater owner has to do the minimum to his theater to accommodate 3D, and he can switch from 3D to 2D very, very simply. Now, let's look at the Dolby system, because it is a very good system as far as quality. In a Dolby digital cinema projector, you have a red, green, and a blue channel, so you can reproduce all of the colors by mixing red, green, and blue, and I'm going to do a further show on color science, and we'll dig into how that works in the human eye. But the human eye has very broad red, green, and blue sensors, and the red and green actually overlap considerably, and they overlap with the blue one. So those individual bands, the reason you see color is you measure the difference between them because they overlap heavily. So all I'm saying is your sensors in your eyes are quite broadband, but there are three different kinds, red, green, and blue. We'll call them for simplicity. Now, what they do in this projection system is they use very narrow band interference filters, and for the right eye, they go to a shorter wavelength in the blue. It's still in the blue band the eye can see, but they have a shorter wavelength. In the left eye, they go to just slightly longer. And so they're shifted, they're offset. You with me there? So the red channel, there's a low blue, a high blue, a low green, a high green, low red, a high red. And then if you wear glasses that have these very narrow band filters in them, the signal for the right eye can't be seen by the left eye. So they separate the channels spectrally. So that's how the Dolby system works. But keep in mind, when you use these very narrow band filters, once again, they take away more than half the light. So you have to use a double the power of your lamp house on your projector. So that's the drawback. Plus, the glasses with the narrowband spectral filters are more expensive than the circular polarized glasses. So here's another diagram of the lamp house, and they put a filter wheel that spins these red, green, blue filters at high speed ahead of the modulator. And then there's an active polarizer here in front of the lens.
A lot like how DLP works, actually. It's interesting.
That's right.
Yeah.
And then here's just a picture of the 3D color management server, the filter wheel projector, and the narrow band spectral glasses.
Now, as I said at the beginning, the guy I talked to, was a special effects supervisor at Avatar, said it was his preference technically for the way it looked for Dolby 3D.
Now, another advantage it has is it runs at 48 distinct picture frames per second.
Okay.
Okay. So 144 exposures per second. So now this got me. Reliability of their systems. In Real D, they have 1,200 Real D systems installed. Cumulative running time, more than 1 million hours. They've had one failure where they lost a show. That's pretty reliable.
Yeah.
So here's the kind of summary, the operational considerations. Eyewear single use for the Real D. You can distribute a voluntary recycling thing, or they can keep it as a souvenir. Optically perfect eyewear every time, very low maintenance, so forth. That's his presentation. So that, in a nutshell, are the advantages of the different systems. So we've gone through all of the different theater projection systems and had a look at how they work. And
do you have a preference? I would guess it's for IMAX, since you have an IMAX theater near you.
I certainly think the IMAX, well, IMAX 2D is just so incredible all by itself, and 3D is even better. But what I think for the typical theater, that's, you know,
I can see why a theater would want to use Real D.
Yeah, you know, a Cineplex over here. I've got an 11-screen Cineplex within 3 blocks of me, and that's where I went to see this.
Right.
They can put in this kind of really high-quality 3D movie system by installing that thing in front of their projector, painting their screen, and handing out glasses.
Yeah.
I mean,
it's pretty easy.
You know,
can you use that new polarized screen
for 2D?
For 2D.
Yes.
So
all you do is get a brighter picture.
So it's good.
Yeah. It just improves the efficiency of your theater.
So there's no negative, really.
No.
Very interesting. I have to say I'm not a fan of 3D movies, but I guess that's neither here nor there.
Right. Now, let me get into why I think they may not make it in the long run. And this is what I'll wrap up with. And I'm going to start with a question, and you're going to say, what are you talking about? What does this have to do with 3D?
Not with you, Ray. I'm pretty much used to that.
Can a person who only has one eye become a pilot?
No.
Or do you need binocular vision to land an airplane?
You need depth perception, and a one-eyed man has... Well, you can. As somebody who has monovision, I could simulate depth perception with minute movements of my head, but I imagine it's not as good as a binocular person's depth perception. You
do not use your binocular vision when you are acting as a pilot
because it's unreliable.
Because the things you're looking at are all more than 20 feet from your face.
Oh, I should have known that from our discussion.
Okay.
So if it's that far out. Doesn't matter.
You get all of your depth clues from perspective, from occultation. There's a whole, I could go through them all, but there's, you look at the trapezoidal shape of the runway, and that tells you whether you're on your glide angle properly. When you land, you look at the far end of the runway and, again, observe the trapezoid shape to know where to flare out.
Yeah, that makes sense.
And you take all your depth cues, and you can get a private pilot's license and only have one eye.
See, I always went on that thing that you have to have perfect vision to be a astronaut. No. I just assumed that you had to have 2 eyes.
No. So here's what I'm getting at. Now, let me tie that discussion back to the 3D. If in the normal real world you don't use your binocular vision for anything further than 20 feet away from you, when you're sitting in a movie theater, most of the time the screen is more than 20 feet from you. So giving you parallax corrected, illusions when your eyes are focused at something more than 20 feet away is not natural.
Ah.
All right? That's one thing. The other thing is, if they really wanted to do a movie where your binocular vision is acting entirely naturally, the whole content of the movie would be objects that were really within no more than 10 feet from you, and preferably 5 feet.
Which, by the way, most things in a movie are not that close.
That's right.
Yeah.
But if you shot a movie that was all about a guy working with his hands on his desk,
that'd be great.
It would be very natural.
Maybe, you know what? That's, I'm going to say that's what bugs me about 3D. It never felt right to me. That explains it.
Yeah.
In Avatar, those way distant trees are in 3D, and the tanks are coming at you, and they're 100 feet away, but they're in 3D.
Right.
In a football game, this is very interesting because everybody's talking about sports on 3D, but you never are that close to an athletic event.
Right. Yeah, they said ESPN is going to come out with a 3D cable station.
Yeah.
And I said, well, wait a minute. If I'm sitting or even in the camera positions at a football game, nothing is within 20 feet of me.
Wow, this is interesting.
And so if they make it 3D, it's not going to be natural. Because when I'm at a football game, I don't use my binocular vision.
Phony baloney.
They have to hoke it up. And it's not
It's
natural.
why it always looked that way. It always looks hoked up to me. It does. It looks like even when James Cameron says we only did 3 effects, the whole movie feels unnatural. And that's why now I understand.
Yeah, because we only use our 3D vision for things that are very close to us. And in those situations, they aren't. So,
which, by the way, explains why a 2D high-res movie image, like a 4K image, can appear completely 3D because you're using those cues, the cues you just talked about, not your binocular vision, to determine depth of field.
That's right.
Oh, that's very interesting. I think a light has come on in my head, akin to the light that came on in the guy who thought about the mirror. You've explained all.
I thought that would give you a different perspective on the matter.
The depth of your perception is amazing, Ray. No, that makes sense because it never did look real to me. And I always just thought it was, well, it's 3D. It's like they haven't got the technology right. But no, it's not going to look real because it ain't.
Well, let me just give you one other quick example of how things have changed. I knew a doctor who did not have binocular vision. There are a lot of people like that.
I know.
Yeah, you're not the only one.
Which is ironic because I do see the 3D and my sense is my eyes are integrating that better than they used to or something like that. Somehow I'm doing it.
But she decided she would not do a surgery elective.
Right.
Because she didn't have binocular vision.
Right.
Now, let me ask you a question. How are most surgeries done today? They don't open you up anymore.
No, arthroscopically.
Endoscopically.
Yep.
And what is the image they're looking at on? It's on a 2D television set.
There you go.
So they don't even use their binocular vision today to do surgery.
Right.
They get their depth cues and touch cues from those probes and,
Well, and as I've always said, even though I didn't have binocular vision, I have good depth perception. I can go like this and match the 2 fingers together because you use other cues. You move your head imperceptibly or using other cues.
Right.
But apparently, at past 20 feet, doesn't matter anyway. Which means
the bottom line
driving
is
and all that.
Maxwell says binocular vision is not all it's cracked up to be. Oh, to wind it up. I gotta say thank you to one of our fans. I of course now appear on iTunes, and you can download the show there. And I want to thank Bruce 3000 for his very, very, very nice comments that he put up a review on the program. He was very kind, but he has now given me a new name, Leo.
What is that?
I am the Geek Father. not the Godfather, the Geek Father.
I think you are the Geek Father. I think that's
so, Leo, I have a deal for you.
Father Geekmas. Yes, Geek Father. You make me an offer you cannot refuse.
Exactly.
Yeah. Stay away from the imitations. That would be my only advice, Mr. Geek Father. Ray Maxwell, you can catch him, Ray, at twit.tv if you have a question, a comment, a suggestion. He joins us live every Thursday afternoon at 2 p.m. Pacific, 5 p.m. Eastern Time. That's 2,000 hours, I think, UTC, at live.twit.tv. And as he said, you can catch it on iTunes. And this show, because it was visual, we will put a YouTube link up at youtube.com/twit. Look for Maxwell's House 54. I'm sorry, 55.
55. Yep.
Thank you, Ray. We'll see you next week.
Okie doke.
What a great subject.
Gonna do some color science next week.
Oh, good. That'll be fun. On Maxwell's House.